All right. Hey, everyone. Thanks for joining us. We're going to start now. We have about an hour time together. My name is Seth Lewis, and I'm the director of the university here at Yugabyte. And it's my pleasure today to deliver today's workshop session, which is, and I'm going to turn off my video, which is, as you can see here, migrating from MySQL to highly available PostgreSQL with YugabyteDB. This is going to be a hands-on workshop. That's the good news that we have in place. With that in mind, let's get started. Again, thanks so much for joining. So about this workshop. So first of all, for this workshop, you're going to need a couple of things. I'll go over what those requirements are. You can see those also in chat. But in particular, this is going to be a hands-on workshop using Gitpod. And what Gitpod is going to give us for this hands-on workshop is a VS Code editor that's a browser. So in your web browser, there's nothing to install. All you need is a Chromium web browser. And it's also going to give us a virtual machine. That virtual machine is going to have up to 4 cores. That's our default. You can have up to 8 cores. And guess what? All of this is free. And you get about 50 hours a month just because you have a GitHub account. So we're going to take advantage of that. That environment's an Ubuntu environment, Ubuntu 22. Yeah. And that's great. That's what we're going to need to do a variety of things. In particular, have an instance of MySQL. That's a database, a monolithic database that we're going to migrate off of to highly distributed PostgreSQL. Yeah. So as I mentioned, as part of that and part of the goals of this workshop, you'll need a GitHub account. That's required. And again, there's no cost to create a GitHub account. That's essentially free. So yeah, you can just sign in and join for your GitHub account. I'll copy those over. You'll actually see that in the chat. And then the other thing that you're going to need based off of our migration, because we're going to do it in 2 steps. We're going to do it first using our Gitpod environment to a standalone instance of a highly available Postgres database, which is YugabyteDB. And then we're going to do the migration to YugabyteDB Managed in a sandbox environment, which is free. So everything's free. You don't have to pay anything. No credit cards necessary or the like. So let's get started. The Gitpod workspace, when we started up, based off of me joining GitHub and signing up, is going to look something like this. It's the environment. Again, it's all browser based. You don't have to install anything on your local machine. It doesn't matter if you're running Windows or Linux or Mac. You just need a Chromium based browser. I'm going to be using Chrome, but you could use Edge, or similar. But that's essentially all you need. So we'll take a look at this Gitpod workspace throughout the rest of this hands-on session. But as we begin, we probably should talk about what we mean by highly available Postgres in some context. So YugabyteDB is a distributed SQL database. And what's unique about YugabyteDB is how it stores data in a distributed manner across nodes in what's defined as a cluster. But it reuses the PostgreSQL query layer. And so what we see in this diagram, the standalone instance of Postgres on the left-hand side. And PostgreSQL essentially has its own query layer, and it has its own storage layer that consists of a write-ahead log and a disk that's going to. But in YugabyteDB, we can have a cluster of nodes that represent compute, memory, disk, network, right? That can be on bare metals, it can be on virtual machines, it can be in Kubernetes, right? So it doesn't really matter what the deployment environment is, other than that sense that we have these nodes. And we have a reusable query layer that's Postgres, which we call Yugabyte Structured Query Language, or YSQL. Yeah. And we store data differently in what we call our distributed document store, referred to as DocDB. And we'll take a look at this at the very end of our session today, in our hands-on session. And we can talk a little bit more about tablets and sharding and partition keys and the like, and how that really works. But DocDB basically essentially takes a table and shards it into to various pieces, which we refer to as table shards, but they're known really as tablets, right? And we use a RAF consensus algorithm amongst tablet peers where we have leaders and followers and so on and so forth. Again, and that's how we manage our the distribution of our data, and which takes care of everything like load balancing of data as well as replication online. So that's the first part of highly available PostgreSQL. Having a cluster environment that takes care of a distributed document store, but any client can connect to any node in the cluster. And what we do here at YugabyteDB, which is of interest, is when we say we were using the PostgreSQL query layer, essentially we're taking all those elements of the layer in terms of the parser, the analyzer, rewriter, planner, and executor, and we rewrite part of that essentially when it's required to interface with DocDB, right? And a tablet, and for those who are curious, is actually a single instance of RocksDB, which is a persistent key value store, and that will persist to disk immutable sorted sequence table files, or SST files, sometimes called sorted string tables. So very different structure. And we're not going to use the write ahead log of Postgres. We use the RAF consensus write ahead log and so on and so forth. So anyhow, but we can be strongly consistent. We can replicate. We have a replication factor of 3 and so on and forth. And a client can connect to any one of the nodes in the cluster, and a YBT server, which is referred to as a YugabyteDB tablet server, YBT server for short, essentially has the ability to host a client. So that when we talk about highly available PostgreSQL or turbocharged PostgreSQL, we're really referring to YugabyteDB and what. Okay, so I won't belabor these slides for too long, and I'll check every 5 minutes or so on questions, because I want to dive into the hands-on portion of this lab, and we'll probably run into some errors and challenges and so forth. But yeah, so when we talk about YugabyteDB Voyager, Voyager it's been out now for a couple of months. The previously release was 1.4, and it affords migration from MySQL, PostgreSQL, and Oracle. I don't know what version of Oracle we go up to. I believe it's 19, but it could be 21. And 1.4 supports offline migration. So an offline migration is when you stop your source database. In this case, it's going to be our MySQL from client connections, right? You're stopping more writes to it, and then you're migrating into the target database. In this case, will be our highly available PostgreSQL database, YugabyteDB. In 1.5, which just was released, I think officially today, but there is online migration. So you may have seen one of the wonderful demos showcasing this. So you can actually be writing to the source database, and then behind the scenes will capture that new write as that migration is going on and so forth. But the online migration currently only supports, I believe, Oracle, and there will be in future releases online migration support for the other databases. If I were to speculate, I would say I don't know what the timeline is on that. But for our purposes, because it just came out, we're going to be using 1.4 in our Gitpod environment. Sorry to disappoint you. But for the most part, all the features and bells and whistles that we need are there. And I'm sure there are more new features. I just wanted to highlight online migration for Oracle's the big. Yeah. So we're going to dive into our pod environment in just a moment. But what I wanted to do before we did that, because we'll see these slides within the environment, is the migration workflow. The first of which is installing YB Voyager, which is pretty easy to do. And in fact, we'll do it automatically for you in your Gitpod environment, but I'll go through the workbook and the file explorer to show you where those commands are. And then we'll prepare the MySQL source database. And essentially, that's just going to be adding a user, a YB Voyager user to that database so they can access all the objects in it. And then we'll prepare our YugabyteDB target database appropriately, again, with the same types of users and roles, permissions, and privileges. So that's really the first phase. This next phase is going into the schema. So schemas are always a challenge. And actually, the term schema is probably more specific to Oracle and Postgres than it is to my MySQL. For those of you who are very familiar with MySQL, like create schema or create database, they're synonyms, right? So the concept of a schema as a logical schema in MySQL is you. But that's okay. For illustration purposes, we can certainly create one in Postgres, and in this case, YugabyteDB. Yeah, which I think represents more about the maturity of Postgres over MySQL, just my humble opinion. So we're going to export the source schema, and then we're going to analyze that exported schema, and we're going to modify it. And what you can see here, I have the fire symbols and the fire extinguisher because we're going to find errors. Whenever we're using tooling to do its best job, just migrate our data definition language scripts, and we're just going to run into some level of errors in syntax. 95% of everything is going to be taken care of, right? But that's one that remaining bucket, right? We're just going to have to manually intervene and put out those fires. So we're going to go through that process in today's workshop. Now, after we do that, initially with the schema, sort of the next phase is actually we have to test it, right? We have to import that modified schema into our target database. In this case, it's going to be YugabyteDB. And we have to find out like, hey, yeah, does that actually work? Our analysis tools, our human reading, we may catch 96% of everything, but that 4% or whatever's remaining, there's still going to be some errors. So we still have a little bit of work to do and resolve schema errors. And so we're going to just rinse and repeat, right? That's essentially what we're going to do until we eliminate most of our errors that we have. Yeah. And then after doing that, then we'll export the source data from the MySQL database. So that's our general process. So make sure our schema can be imported into our target database. And when it's ready, then we'll export our source data. And then we'll import that source data into, in this case, YugabyteDB, our highly available PostgreSQL database. We'll import if we need to indexes and triggers, and then we'll verify the data, make sure it works, right? So it's pretty straightforward in terms of a migration plan. Yeah. There's some challenges that we're going to face with migration from MySQL to YugabyteDB, highly available PostgreSQL. And we'll point these out as we go through the hands-on workshop in the Gitpod environment. There are a couple of main differences that are gotchas here that we need to be aware of. Oftentimes in a MySQL database, folks will use a primary key of the type integer, and it will automatically increment. So every new row they insert, that ID value, for example, is the primary key of the int that's auto incrementing. The first row will be 1, the second row will be 2, and so forth. And you can change the seeding or whatever it is, but when that increment starts, but essentially that's how it works. And it's very convenient. But in PostgreSQL as well as YugabyteDB, we don't have that same type of construct of an auto increment. And instead, we have serial data type, and that can be small serial or the like. There are several. And behind every serial data pipe is a sequence, right? That's one consideration. And then the other consideration that we'll touch on at the very end of our workshop has to do with primary key definition and sharding and the like. But we have to be aware that what a primary key is in YugabyteDB. It's going to be a partition key and clustering keys. Yeah. And so we just have to be cognizant of what that is. The other thing in MySQL, oftentimes you'll see developers do this. They'll use a tiny int or small int or an int as a Boolean value for a flag, true or false. And it's just a convenient thing to do sometimes, to do a 0 or 1 versus true or false. But anyhow, but with YugabyteDB in PostgreSQL, it's going to be best to say, hey, we want a Boolean. And it's not that you can't define it in your data definition language statement. You certainly can as a tiny int or small int. It's just going to be in some of those downstream views and so forth that are going to help application logic, where you're doing a case statement or something like that, where you're going to be using tiny int or Boolean, you'll run into some conversion. So just be heads up on that. Then there's another aspect of MySQL, especially the version we're using, MySQL 8, has support for geometry shapes, right? So a geometry could be something like a line or a polygon. And there's several different formats really for geography type shapes, right? As well as the support for indexing geography types. And I think there are three different ways that MySQL can store a geography type. One is as binary, another might be as text, well-known text, WKT, and so on. But with PostgreSQL, there's support for geometry type sims, but unfortunately with YugabyteDB and at least our current version, we certainly don't have support for the gist index, and we have like low level support for geometry, and certainly not yet for geography, right? So that's a gotcha there that we will come across. And then another gotcha is going to be like specialized functions. For every database will have this, right? But in particular, MySQL has one that folks like to use quite frequently, which is group concat. And yeah, and it's a really nice function. You could get around it with window functions and so forth. But in Postgres and YugabyteDB, there are a couple of different options for dealing with how those sort of standard uses for group concat, like string add or array to string and array add, to convert those. Yeah, and there are certainly more, but this is our high level challenges that we'll face in today's workshop. So that's all really I had for the slide. So I'm going to switch over here and just check here. Yeah, we have the links that you're going to see, and the slides. No, we don't have a current link for the slide, but these slides, I would generally say, and everything that you're going to see in the Gitpod environment are going to be shortly available by the end of the month at our university.yugabyte.com as a course, and then you'll be able to download it. Yeah, but the main thing that we want to do now is switch over here. So let me stop sharing real quick, and I have to share my other screen for YugabyteDB Voyager. So this is our repository that we have, the links in the chat, and you can click on this button here, opening Gitpod or YugabyteDB Voyager. Again, you'll need to be signed in to your GitHub account. So I'm signed in a profile to use something called Gitpod. And so either you'll see this button here, or you won't. We have the README here that will tell you what you need to do. To if you want to use the browser extension, but really all of that is not necessary. What you can simply just do is click on this link, open in Gitpod. So either this is going to work or not. But the first thing, let me just make sure you guys are all seeing this. Perfect. Is when you select that link, you're going to be asked to create a new workspace. Again, this is free. You get 50 hours a month of workspaces in Gitpod. You can look at the README file later on to see all the details. But there's really nothing you need to do here other than to leave this as VS Code editor browser. It's going to run and just use the standard class cores. There are other options for larger. We just don't need to burn extra carbon unnecessarily. So let's just conserve the energy that we need. And we'll run on four cores. Yeah. And we can spin up a standalone YugabyteDB cluster on even such a small instance using the loop addresses that are afforded to us Ubuntu. So once we do that, we'll select continue. Now, if you're doing this for your first time, we might run into a build screen. Yeah, pulling the container image and so on and so forth. And that might actually take you a couple of minutes. It really depends what's going on with Gitpod and how it's going to pull the container image that's in place. So while that's happening, and I'm pulling that container image, you might start seeing an output on the screen down below that shows everything, the steps that are being used for the build. But in the meantime, while that's happening, I'm going to go over to cloud.yugabyte.com. And let me share. Yeah, there it goes. My Gitpod is up and running, and it will just take about a minute or two to start up. And we should see something here in the terminal, creating the cluster, waiting for the cluster to be ready. And if everything works swimmingly, we should see in the output in the terminal that we have a 3-node cluster running replication factor 3 is up and running, and so on and so forth. Yeah, and you don't really need the terminal from this point on for this case, most certainly. Now, if you're waiting for the build to happen, which some of you might be, in this case, let me just share here, stop sharing my screen and share this other part of the screen. You'd probably need something called YugabyteDB Managed. If you haven't already, there's a link here there in chat. You can go to cloud.yugabyte.com, sign up, and put in your company email address, first name, last name, password, and I am human. This email address, you're going to receive an email verification, or verification email, I should say, where you're going to have to click a link. So make sure it's valid and that you can actually click on the link. Otherwise, you won't get past go. So I've already done that. So I'm going to log in to my environment. I'm going to use my son's account. And hopefully that works. Okay. Yeah. And if you haven't already, what you can do is with YugabyteDB Managed, you can create a new cluster, add a new cluster, and we'll have some steps on how to do that. But it's pretty straightforward. It's a sandbox cluster. It's free. You can use AWS, GCP. There's a step for downloading your user credentials. It's a download file. You'll need to do that. Yeah. So just for time's sake, our assumption is that you can do that on your own. In the meantime, let me move over here back to the Gitpod environment. Okay. And confirm that we're seeing that. Awesome. This is the VS Code as a browser. We'll have everything from the repository is here that we have in place. If you're curious about how this works or runs, you can look at Gitpod Docker file. This is where we're pulling the download for our instance on this Ubuntu host for YugabyteDB. This is where we're pulling the repository for Voyager. Yeah, that we're going to install. And we're going to install version 1.4, be very specific, which requires the museum. And there's a different procedure for 1.5, but that's because it was newly released. We're just going to skip that. Yeah, but we'll untar everything. All this is what happens behind the scene for your Gitpod environment. And you may notice that we're actually using a special Gitpod, a Docker image that has MySQL in it. So we just took a plain vanilla MySQL, a Docker image that Gitpod offers for developers for a place to. We had a couple other steps after we actually started up in your Gitpod environment. And so if you're going through the build process, you'll see some things related to this. Here are some things that we'll use for our notebook environments. These are Jupyter environments. So basically IPython and the like, SQL parse, SQL alchemy, and so forth. The MySQL connector for Python if you want to use that. And then some commands just to import data. A lot of folks will recognize the SQL database. Yeah, as a standard database. There's nothing new there in terms of modifications. It's the one for MySQL. And we just spun up a 3-node cluster using YBCTL. We could use YugabyteD. I just didn't have time to do that, but either one, it doesn't really matter for demonstration purposes. So that's how this environment got to place. Now, the most important thing when you're in this environment, as you're following along, is to select your kernel, which is going to be a Python environment. So you'll see that here, Python 3.4. So at any point in time, too, you can go through an outline of the notebook. So everything's down here to any function. So this is a nice way to navigate versus sort of your Explorer and so on and so forth. So now that I have Python in place, in my requirements, if you want to learn more about Jupyter notebooks and how to use those, a lot of data scientists know how to use those already. But yeah, here's some commands that might be helpful. But for the most part, you don't need those commands. What we just really need to do is run this first one, which is very important, which is our environmental variables. And this is going to capture some things about the Gitpod environment that we'll need, like path and the host. You'll notice everybody gets a different host up here and so on and so forth. So we'll do that right away. And we're going to store these in what are known as variables for the notebook. We're just using Python. That's the cell that's doing that. And you'll see here, if I select variables for Jupyter, you'll see all those values get populated here. And we don't really need to look at those or modify those, but that's just helpful if you want to understand, like, oh, if something's not running, it's probably because your variables haven't been set because you didn't run this sort of first step with the down arrows. Okay. And then the next thing we're going to do is, as I said, we've already installed and downloaded based off of our Gitpod YAML files or Docker files, Voyager. And we're just going to confirm that's the case. Now, notice we're switching from Python to shell script. That's one of the advantages of working with a Jupyter notebooks. You can just switch between environments. Yeah. So you can do that. So now I'm going to select DB Voyager, and you'll see here's my commit hash in our current version. So we have Voyager installed. Cool. The next thing is, let's just see here if we have a database in our YugabyteDB cluster. The first command here is just going to terminate any existing connections. I don't have any. And then we'll create a database. The name of this database is going to be DBYBU for Yugabyte University and so forth. And you'll see that listed. So we're using the YSQL shell on this local instance, our Gitpod instance in our YugabyteDB cluster that we see here, 3-node cluster, to create a database called DBYBU. That will be our target database. For later on, we have some different sort of utility functions. We're going to talk about sharding. We're just going to run these scripts. Oh, basically, we're creating some internal user-defined functions as well as some other stored procedures, functions, and views for gripping metrics from YugabyteDB and cluster environment. Okay. And then lastly, at this sort of first step for the lab setup, we want to go in and we want to test our connection string here for Python. This is going to be to our local host on this instance. Yeah, and we can reload what they call SQL magic, which will allow us to have essentially a really nice way to be able to write SQL within a notebook cell versus doing it in a bash or doing it in Python, which can be a little cumbersome if you've worked in those environments. And so you can see here, I'm just going to query the database in this internal function called version and just get a result. It's something like this. Cool. And that's the version that we're running of YugabyteDB on this host. Now, that means we're set up, which is good news. So that's always half the battle. And we're going to run this next command. This command is going to open up O2 migration workflow. It's an internal command to Gitpod. It's just going to open up the file for us and make our life easy. So you can just click that versus accidentally clicking the wrong one and losing sort of the series of steps. So as we begin here on our second notebook page, we have to, again, always select our kernel that we have in place. So we've already done that. And then as I scroll down, we're going to take those variables that we created in the first notebook and share them with this different file, this notebook file. And we do that here using the store read command for all our lab variables. And that's how we share variables from one notebook, just using this. So pretty straightforward here. Now let's take a review while we have it of this database that we have, the Scala database for MySQL. This is a relational database, right? And it has many different tables that are associated with it. These tables have foreign key constraints. YugabyteDB supports foreign key constraints and the like. It has views, it has triggers, and it has stored procedures, right? So this is a pretty simplified ERD with the collapsed columns and so forth. But that just gives you the idea, like, yeah, this is it's a modest database for sure. It's not thousands of tables or anything, but it's certainly one that represents the capabilities of MySQL, let's say. So our goal here is to get this into YugabyteDB, our highly available PostgreSQL database that we have here. So we can actually use the MySQL CLI to take a look and see what these tables are. So we'll review that. Now, show table status is an interesting command because it does use the information schema to collect the row counts per se, which may or may not always be accurate in MySQL. For the most part, if you don't have a lot of data, they're accurate. But if you're doing a lot of ingest or so on and so forth, yeah, they might be a little suspect. But anyhow, so these are the tables that we have and all the details about the tables associated there. And then we could show full tables like the type view. So here are the views that are associated with this database. There are numerous indexes that have been created, right? That you can see here for this database. So lots of different database objects is really my point, right? As well as user defined functions that we have. There are triggers that are associated here, and then even procedures, right? So yeah, the database has a whole gamut of objects, right? As this is an example database for MySQL that typically I would say in the real world, anybody would would be interested. Yeah. Now we can take a look here at our next step, right? So we have our source database, right? And now we've already installed YB Voyager, but we need to prepare this source database and then prepare a YugabyteDB target. So we've already done this, but if you want to know, good news, we already have it. But if you want to find out how to install and download and install Voyager, the links are here in this Gitpod. So the first thing is we're going to prepare the MySQL source. I'm going to do this in the Python cell just for convenience. And essentially, they're just a series of I would say privilege statements. We're going to create a specific user on the host. We're going to give them specific grants, privileges, right, to process or select or show or trigger or flush, and so forth, and store procedures. And essentially, the reason why we're doing that is so that that user that we're creating, in this case, the YB Voyager user, host 127.0.0.1, can access all those objects that we just reviewed. So those are the SQL statements, and I put them like in an array construct, and we'll just through Python, we'll just circle through them, right? Loop through them. So that's all we're going to do here. And it said, yeah, this is what we did. We created the user, then we gave the grant. So pretty straightforward. And there are a bunch of different ways to do it. I just wanted to make it easy that way so you can see the SQL statement. Now, for our YugabyteDB target, we're going to come up with a target database name, and we're going to create a database. And remember, there's no concept of really a schema in MySQL, but there certainly is one in Postgres. So we'll create a schema associated with this database later on. Yeah, just so you can see that's something that we can take advantage of. But before doing that, we're going to just create in the target database in YugabyteDB a YB Voyager user and give them a password and so forth. So it's just plain and simple, but you can modify this however way you want to. So now we have a database called DB YBU, and we've created. Okay. So that was pretty easy, but we haven't done the hard work yet. So let's open up the third notebook. Again, the standard steps, choose your environment. I'm going to just choose 3.11, whatever it is that you can see here. Import the notebook variables. That's how we share this information. You'll see a little check mark here. And then let's talk about the migration workflow. You're going to export the source schema, all those objects, the DDL related to those objects. And then we're going to go through a process of analyzing that exported schema and modifying it accordingly. And the nice thing about YB Voyager is that it's going to help us with that analysis, right? It's actually going to give us a report telling us some things to fix. And that's the good news. It's going to do a lot of the heavy working when it does this. I would say the heavy work when it does this export of figuring out how that MySQL DDL should go over and be translated in a PostgreSQL DDL that's compatible with YugabyteDB, right? So we're going to export the source schema here. We're going to do that in this cell. So we have a notebook Voyager temp. That notebook Voyager temp, and I'll echo out that directory, is here in our Explorer. And I have a file there called nada.txt. It says hi or whatever, but it's a nothing file. Just so that you know that this is, we can read this directory. Okay. And we're going to create a directory called export directory here. And if it exists, we'll nuke it. But if it doesn't, we'll add it on. Right. So there. Okay. And so you'll see this export directory now exists. Okay. Now we're going to export the schema using the YB Voyager CLI. So that YB Voyager is a pretty powerful tool. If you've seen some demos with 1.5 and Yugabyte D, you'll see some screens about when migrations are running and so forth. But there is a CLI in 1.4 that that's what version we're using. And we're going to use the export schema command. And we're going to pass in the parameters start clean. So if something was already there, we're going to nuke it, whatever it is. We're not, because we're running in this cell, we're not going to respond to any prompts or anything like that. And we're going to say, this is what our new export directory is. This path here that we saw in the workspace is captured by this variable. And when we use these cells, for those who are curious in the Jupyter notebook, we're basically reading the variables here into bash, and we're substituting them by ordinal position into these local variables of the cell. You'll just see that pattern on and on. If it's in Python, we have access to everything, but if it's another sort of programming language, sometimes it's a little quirky, and that's just what you're seeing here. But that's how we get the path in here. It's ordinal position number 4, starting with 1. And so we have our DB host, our port, our name. That's the database we created recently. And we're going to use the user Voyager and our password that we specify. Okay, great. We're cruising along here. Okay, and what we'll see here is our export directory is now filled with these items. Cool. Okay, so we have report, schema, data, meta info, and there is a log file. So I showed you here in the Explorer, but you can also just do an ls of the directory to see that as well. Let's take a quick look at the log file. Now, there are a couple of things here. I've done this in a couple of ways. The first one is we can cat it out. You might have a settings here that you can check. There might be something that says adjust cell output settings. You can click on that and follow these steps. Go to notebook output, scroll in, and change the text line limit to 200 or so forth. That will give you the last 200 lines. And you can see here, this is what the log is saying here in terms of creating these files in that export directory that it has here. But you can also look at it just as the log file here, which is going to grow to be pretty log. So if you want to keep that open, you can, or keep it closed. It's up to you. Just make sure if you turn off or close one of these notebook tabs, you just reopen it and start from the beginning. Okay, so that's the first thing. Now we'll analyze the exported schema. We're using the analyze schema command, and we'll generate a report, so to speak, in an output format of text, but it can be JSON or HTML. So it said, hey, I generated this file, and now we can look at that reports directory and we can open it up separately. Either or. Yeah, back on this one, you'll see here that the output, but here's the report text as well. And at the very end of this, you'll see that we have an issue. So I'll jump back over to the notebook to identify that issue. That issue has to do with that GIST index that we had before. And so, of course, so we have indexes, table.sql is where that file exists. We can take a look at that if you want to open it and take a look, but essentially it's here, this line that we have. The easiest thing for us to do, just for our demonstration purposes, is because we don't support that index type, there's really no point to have it. So I'll just use a bash command, but you could do this in the indexes table.sql file. But this is just going to essentially remove that line, right? So if you go back in, and now you can see it's gone. So we just basically deleted that index. And you can verify that's what you did in this case. So you won't see it here. So we took care of that index that's not supported. Now we need to do the rinse and repeat. We want to analyze that modified schema again. So we're going to run the analyze schema again. And this time we don't see an error when we open up the report.txt file, and the output of the cell also reflects the same type of thing. So no errors, nicely done. And we can confirm that and so forth, right? We want to look at the table definitions for the primary key. That's important to do. And you'll notice the export tool has taken those IDs that were of the type auto increment integers, primary key, and has made those into serial. And we'll come back to why that's important a little bit later on at the end of our session. But essentially, if we want to take a look at another way of this, the summary of that is we have a bunch of primary keys for these types of tables. And in particular, if we were concerned about data modeling, there are a couple here, the primary key, that where we have composite keys that we'll want to take a look at and scrutinize in probably a little more detail a little bit later. But yeah, that's fine. For now, there are some considerations with secrets, migration, and caching for clients and that we can get into. Those are more deep dive topics, but those are just things you'd certainly want to address a little bit later on. But for the most part, this initial export of the schema and analyzing problems has been resolved, right? Anyway, I'm going to close some of these other workbook tabs because they're beginning to pile up. You don't need to leave them open if you don't want. So I'm going to just go on to workbook number 4 here that we have featured. And again, select your kernel, run the cell for your notebook variables. And let's look at the second step of the schema. What we want to do now is try to import that modified schema and see what errors are thrown, and then modify that schema as needed. Yeah, and then we'll export our source data. So this is probably an area where we're going to get all those, that 5% of things that Voyager couldn't figure out, we're now going to be able to identify, right? Because YugabyteDB is basically going to say, hey, I can't create these objects. It's not working. Okay, so here, import schema help is the command here for all the sort of variety of flags that we have, and so on and so forth that we can take a look at. And we're going to use the one called import schema, and we'll start clean. And that's going to use this directory, the export directory, with all the objects that have been defined in SQL files and so forth. So it's going to try to import that schema into our standalone instance of YugabyteDB. And what's going to happen is, as you can probably tell, as we're following along, is we're going to run into errors, right? So we have our first error has to do with order by or distinct, and we have an error code. This other stuff that you see here, this just has to do with the Jupyter Notebook and IPython. So you can just ignore this stuff. It's just error messaging, what's going on. We're interested in this error at the top. The rest of this stuff, just ignore. It's not important. It's just for the notebook itself. Resolve the schema errors. Let's take a look, and we can see here, looking for SQL state. We have a bunch here, but one in particular has to do with address. We have something related to this address table with sequences or triggers, another view, and so on and so forth. But really what it comes down to in our first error is table address. We have this geometry error doesn't exist. So let's go here, show create table address in MySQL, and take a look. So this is the MySQL definition, where we're going to find here the geometry location is geometry type, right? And then the data itself, when we did a limit 1 on it, it's obviously in some type of binary format. And I was mentioning earlier with MySQL, there are a variety of formats. There's well-known text for geometry, well-known binary, and internal geometry format. So it's either one of the well-known binary, internal geometry. I think it's the internal geometry. If you want to find out more details about it, there's here that you can take a look at supported data types and so forth for YugabyteDB. But from my point of view, we just don't need that. Like, we can't support that data type, but we certainly support some type of byte array. So that's what we're going to do. We're just going to basically put this as a byte array into that DDL. Let's go along here, and you can see here we've changed in our schema that we're going to import. We change this essentially location to a byte A. Yeah. And now let's resolve the remaining errors that we have. And there are going to be still some more. So we have a couple of more here that we're grepping. Let's move on to the next one. This has to do with the view, create a replace view customer list. Now, interestingly, something happened here with zip code. If we were to take a look at this, there's no underscore. That's probably a known issue, probably got resolved in 1.5 of Voyager. But we just want to replace this with an underscore. So that's what we're going to do. And we're going to go in here and do that. There's the views file itself. So we've made those changes. And if you want to see what that difference is, you can see here, we've changed this to zip code that we got. That's why this import is important to do. So the next one is we're going to do another import again, right? So we're going through the rinse and repeat cycle a couple of times. And we're just trying to figure out what these errors are. And there's probably a better way to do it, but quite honestly, this is with any data migration, we're just going to run into this. So here we have another one with an order by and a distinct clause with some type of view. It's within customer lists. So let's take a look at that. Yeah, that's being thrown up from our SQL state. So this customer list one in particular that we have here relates to the create table statement, and it has to do with this case when statement must be of type Boolean, not small int, right? So that's the error we're running into. So what we're going to do is just change this value in our exported schema for the active small int. We're just going to change it to be a Boolean, and we'll do that. So now we've changed this, and we've done that for Boolean. Okay. And we can confirm that we made those changes, and you'll see that active is now. So we're just modifying the schema files, essentially. That's all we're doing, just so that they'll work and import. So we're going to do another rinse and repeat. And the process is pretty quick, as you can tell here in the notebook, just to facilitate as we're going through. And now we're going to run into another type of fun one, with something that has to do with the distinct and order by clause that we see here. City must appear in a group by clause that's associated with it. So we'll open up the view file that we have here, and we're just going to take this solution we have here and use it. It has to do, MySQL is pretty lazy in terms of dealing with group bys properly, right? Whereas Postgres and other databases, they basically insist that you must specify something in the group by clause. So that's all what we're doing here. But to facilitate things, make it easy, we'll just do sales by store. Now, there is another view here that's going to cause problems. And it has to do with our group concat. It's this one here called actor info. And just to make our life easy, we're just going to comment it out for now. It's a more complex query, and it's beyond the scope of what I wanted to show today. But for when we have our launch, the official course at Yugabyte University, we'll certainly have the solution for this. But just for time's sake, we're just going to. So we replace this one, sales by store, and we're going to get rid of this actor info one, just for time's sake, and then we'll just save that and close that we have here. Okay, so we'll rinse and repeat. And let's see here. And that works. So this is really, can we make it or break it right now? Can we create this import schema that we have? Now, importing the schema should just take a couple of minutes, a couple of seconds in our case, but it could take a couple of minutes in a production environment or state environment, depending how many objects you have. So we're good. So let's do a little sanity check to see what we have. So here we have our schema, and our owner is YB Voyager. And we have some tables that we've created. We have, our views are here and so on and so forth. And we have indexes and everything that were essentially created, right? And then we can even look to see what triggers we have. So it's a variety of objects have been created, right? And that's good. We didn't have any errors, right? Now, at this point, what we're going to do is export the data from the source database, right? I think that makes sense to do that now. And you can see here, export data, these commands. You can export this data, and you can put it up in an S3 bucket, or there's a variety of other things that you can do to move it from one environment to the other. But essentially, when we run this command, it's going to create that data in our export directory by default. And it's just going to be a series of files that you'll see here under data. Now that should take just a couple of minutes. You'll see there's an export status, JSON schema status, and then you'll see the DDL segment. Everything. Cool. Okay, and we didn't run any errors, so I'm not going to kill the process. Yeah, and if we look at our log here, a log file at the very end, which is grown pretty long, you'll see that we have a bunch of statements referring to the file path and where we created the Okay, so that's good. Yeah. So next up is going to be, let's talk about import. So I'm going to close this this one in a moment, but first I need to select my kernel. And then from there, I'm going to import my variables that you see here. And we're going to So now that we've exported the data, we've already imported the source schema. We're pretty good to go. We're just going to try to import that data if we need to update any index triggers and verify that data. So we're almost near the home stretch. So here's our source data. It's going to be the export directory, and we're going to import data. That's the command that we're going to use. And we're now taking those SQL files and running them and processing them using YugabyteDB Voyager. You can parallel, there are flags to for parallel processing and the like to make it faster, depending on the number of cores you have and so on for ingest. And now we can check the status of this import. And you can see here that we've imported the data, and here are some associated row counts. And we would compare that to our first notebook and what we had from MySQL, what the tables and row counts. Good for us to do. If you want to learn more about details about how you can import data from cloud storage, here's a link here to our documentation. And then another one is for import indexes and triggers. We actually, those, like, all that's been addressed. We're just going to skip over that for this case, but we'll verify the migration for our standalone Yugabyte instance here that's running on our Gitpod environment using SQL Magic. And you can see I can just run some queries. So now we're querying the database here, and we're looking at the actors. And you can see here the reference to the schema name that we've actually adopted. Again, it's not required. We just did that to flex our muscles and to show it works. Okay, cool. And the last steps we would do here would be like to clean up the migration user on that target database, in this case, YB Voyager and so forth. And if I wanted to delete the temp directory. Okay, so how do I do this in YugabyteDB Managed? I've already jumped ahead and started over an instance of YugabyteDB Managed. So let me just stop sharing and share the screen here for YugabyteDB Managed. So I already have an instance of YugabyteDB Managed in running. I've called my cluster MySQL. Log into that, and we'll see that the screen. Okay, cool. And we're going to use this cluster environment. Now, there are a couple of things that I need to do to get this to work. The first of which, my cluster has an IP allow list that's associated with it. If I look at my cluster here, they have, and let's see here, edit IP allow list. So I have an IP allow list. Now I need to know what my Gitpod instance is my challenge, right? So we can grep that and then we'll add it back. So hold on a second as I toggle between screens. Thanks for your patience. I try to do this wizardry behind the scenes. Yeah, let's share the Gitpod environment. So we'll select our kernel first to do this. And then we'll get within here, we'll get all our variables for the notebook. We've done that. And now what we need to do is get the Gitpod address. And we're just going to curl like IP info IP, like just do something like this. And maybe I need to run it twice. There we go. And I finally got it. It's 35.23.3.252.202. I need to add that to the IP allow list that we have in. So let me just stop sharing here and then share other tab. For Yugabyte Managed. And I need to add it to add an existing IP allow list. That's going to be under networking, IP allow list here that we have for this one, but I'll make another one. And this one is going to have this address, and it's going to be called pod more. Just for two. Okay, cool. So there's my new IP allow list. And then back on my cluster, I have to, I don't want to do that. Hit the wrong button. I want to go in to my cluster environment and then add here edit the IPLL list, and I want to add an existing IPLL list, which in this case was my Gitpod more. So this is a new one. Every time you spin up the Gitpod environment, you get a new hosted environment, right? So this is one I tested earlier in the day, and this is one for now. Or you didn't select that and select save. Okay, that's going to allow this notebook environment and this host to be able to connect to YugabyteDB Managed in my sandbox cluster, which I called MySQL. So that's the first thing. The next thing is I need to download a CA cert that's associated with this cluster. So if you go to the connect button and I'd say connect to your application here, there are a couple of things that are going to be helpful for this. So the first of all is this CA cert file, or it's going to be root. I have an existing copy here that you have. And then the other thing that's going to be of interest to me is essentially this host, US East 1, and so on and so forth. So I'm going to copy that. Yeah, now I'm going to switch back to, as we stop finishing up here in the couple of minutes, let me switch back to my Gitpod environment that we have. Okay, cool. There are a couple of things here. The first is this host name that I have. That's my host name that I have. I have a user that I created when I spun up my cluster, admin, password's Yugabyte #1 that I'm going to use. And then I'm going to put here in my temp directory that we had earlier, I'm going to put a root folder. And I had that from earlier. So I'm just going to drag and drop it right here. And you'll see now that I have, with under temp, I have my root directory, CRT file, my credential. Okay, so that's the first thing here. Right now, I have an existing database called DBYB because I did this earlier, but we're going to use the host, our root file, and we're going to drop the database and create a YugabyteDB Voyager, a user that's special for the YugabyteDB Managed environment. So let's see if we can connect and if all that works. And there we go. So we're running our YSQL shell commands from this host, connecting to the YugabyteDB Managed sandbox cluster, that host that's up in the cloud. And it says, hey, you already have this user that exists. That's fine. I'll just leave it at that. And verify that the user could connect. So that host, add your host here. I got to do that wherever it is. And then I'll just run this again. And this will verify that I can connect with the DB Voyager and the password, and we'll just run select one. And that means I could connect to the database. Now, I'm going to import that modified schema that we had before that we spent all that work on. You'll see that I'll do that right here. And I'm using, again, the target host. And what's going to happen is I'm going to create all those objects just like I did on my standalone, or I should say my YugabyteDB cluster in Gitpod. Now I'm going to be essentially doing that in YugabyteDB Managed. This is a really good approach where you're working in your local environment and so forth, and then you want to go up to the cloud. How can you do that? It's really simple with YugabyteDB Managed. And we'll have a sanity check here. Again, I have to, and I could done this and we'll improve upon this, but just for time being, using your host here. There's a YugabyteDB Managed API, so we could get the host name. There are lots of things that we could do to rep this programmatically if we wanted to, or to script all this. But essentially, here we go. The sanity check is showing here is that we have the YB Voyager database and schema. So we're now going to import the source data. We need to change the value here to use our DNS host for YugabyteDB Managed in this notebook cell. We're going to use the import data command, and we're just going to run this just like we did earlier for our standalone instance or cluster in Gitpod, but now we're doing it YugabyteDB Managed. And this should take just about the same amount of time, quite honestly. Yeah, so I expect it to be less than 1 minute. Let's see. And there it goes. It's about under 30 seconds. That's pretty good. So we're using the export files that we have here in this Gitpod host. We're connecting to our YugabyteDB Managed cluster, and we're importing this data after we imported the schema. The next thing here is really to check the status of that import and see where we're at, how many rows. Everything looks really good. And let's verify the connection. We're going to connect here to YugabyteDB Managed using the PostgreSQL driver for Python. Excuse me. And then from here, yep, we've made that connection by updating the managed host connection string. And there you can see we're going to run a query, and ta-da, yeah, we have 2 results. So all said and done, really pretty easy. If we go back to our cluster in YugabyteDB Managed, we can see here that we have our tables. And it should take a second or so, 19 tables. The database size will probably update in a few more minutes after the import. Sure. So next up is our demystifying table sharding. And that's about it. For those who are curious and want to continue on learning about how we shard data as a distributed SQL database, highly available PostgreSQL database, you certainly can go on to this next step about demystifying table sharding tablets and data distribution. This will run locally in your environment. Again, you can run and so on and so forth, but it will go through the various steps talking about like how we create a primary key, what that looks like, how do we shard data, how we use consistent hash sharding, range hash sharding. Again, thanks so much, everybody, for your time today.